Good afternoon. Some people have expressed jealousy over my field site, and I want to extend an invitation to anyone here who'd like to join me next summer in Dusy Basin, Kings Canyon. You're welcome to come up and help me catch frogs. It's a little bit of a hike, but it's well worth the view, as you can tell. Can everyone hear me? Yes? All right. Okay, so I'm going to present data collected by a number of individuals over the last 9 years. I've only been with the project starting this field season. So, for instance, two people here, I know Karen Pope and Rob Grasso worked on this project in years past. The three people mentioned here, Kathleen Matthews, myself, and Igor Lacan, are current employees on this project. So, one of the questions we have started to explore, and this is just a very preliminary look. I'm not going to show you any detailed statistics or anything. It's just a first look at this data. And we're looking at, do variable snowpack and lake water levels affect recruitment in the Rana muscosa? So our study site is on the, where is this? Okay. On the northeastern side of Kings Canyon in California, and fairly high up, 3,400 meters. So over half of the year, the area is covered in snow. I'm hearing a lot of talk in the back. Okay. So we're looking at this one study area, and there's 15 lakes in the area, and they're mostly small, clear, and shallow. There's one lake, which is, you can see the names here labeled, Lake 1, that's deep and fairly big. It's 10 meters maximum depth, over 400 meters wide. The rest are very small, no more than 2.2 meters deep. And so they may or may not persist during the course of the summer. As you probably know, the ponds dry up. And we think it's linked with snowpack and summer precipitation. That's one of the things we're going to talk about today. So as you probably know, the whole area was historically fishless, and then over 150 years ago they started stocking. They're not currently stocking in this park, but most of the permanent lakes still have fish present. In our study area, there's fish in Lake 1, and in the stream leading to 3, and the stream leading out of the area. So you probably know also about Rana muscosa, and that it's endemic to the Sierras, and it has a long aquatic tadpole stage lasting at least 3 years. The adults are fairly long-lived as well. We pit-tagged individuals in 1997 and recollected the same individuals in 2005. So we know they've lived at least 9 years as adults in this area. And their range has declined significantly, 90%. Kathleen showed in the past, trout is affecting them, and other factors like UV, pesticide drift, disease. And it's warranted for listing with the Endangered Species Act, but it is being waitlisted like other individuals. I just wanted to highlight that if the adult lays eggs in, say, 2002, we wouldn't even start seeing metamorphs until 2005. And here's an example of metamorphs. When I'm talking about recruitment later, I'm focusing on these metamorphs that have just emerged from being pre-metamorphs tadpoles with 4 legs. So just as a sneak preview of what we're seeing up there, this map shows the breeding lakes in Dusy Basin. And the darker red has more egg masses seen, and the lighter pink are fewer egg masses. And this is showing you the maximum number of egg masses seen during a year, the beginning of the breeding season. But the same trend holds if I were to show you average egg masses or total egg masses. So 87% of the breeding going on in Dusy Basin is taking place in 3 lakes. This dark red lake, Lake 2, and Lake 5, and Lake 20. The rest are fairly insignificant for egg mass laying, and half of the egg masses, you can see that more egg masses are being laid in Lake 2 than anywhere else. The problem with this is Lake 2 has dried up 4 out of the 9 years that we've been up there. And remember, the tadpoles need over at least 3 years to metamorphose. So this is obviously a bit of a problem for them. This is Lake 2, by the way, in 99, I think. Anyways, the beginning of the season and the end of the season. So one of the questions, again, that we're looking at is there a link between lake water levels and snowpack? Snowpack is pretty variable in the area. It varies year to year. Also, the lake water levels vary year to year and during the course of the season. The top 2 photos show, these are all Lake 5, by the way, and the top 2 show a high snowpack year in '98 and a low snowpack year in 2003, and at the same approximate time of year. The bottom 2 are showing drawdown during the summer. So the blue line here in September 2002, the blue line is showing what the lake water level was at the beginning of the season that year. And this was a particularly dry year, so the lake dried up quite a bit. This lake doesn't dry up completely, but obviously you're seeing a significant amount of drawdown. And comparing 2002, which was fairly dry, to 2005, at the end of the season, there was still plenty of water here. So does snowpack affect and lake level affect recruitment? Today I'm going to walk you kind of through our thoughts on this to evaluate the question. First, we're comparing year-to-year snowpack and summer precipitation levels with summer lake drying. Then comparing recruitment in breeding lakes prone to drying with breeding lakes that are not prone to drying. So first I'm going to show number of egg masses and tadpoles seen in the breeding lakes, show which lakes are prone to drying, and showing the number of metamorphs seen in these breeding lakes. So first we're going to look at snowpack and lake drying. There's a lot of information on this slide. I'm going to walk you through it slowly. It's showing on the depth, basically, of snow, like the maximum snow depth per year. So, for instance, in 1998, the snow started falling in like October or November of '97, and it reached its peak, I think, in May or so of '98, and it got to be about 48 inches. The snow then starts melting, and by June or July, it's pretty much gone. But the next thing I'm going to talk about is the difference in the colors here of the bars. Is the blue ones show our 15 lakes all had water at the end of the summer, whereas the brown reddish bars showing our lakes, some of the lakes drying. So why are they dry? Well, the blue in '97, '98, and 2005 were high snowpack years, lots of snow, and none of our lakes dried up. In looking at the lower snowpack years, only 2 of the years did we have our lakes full of water by the end of the summer. And the difference is probably due to high amount of precipitation during the summer. There was about 2.5 inches between July and September in 2001, about 4.5 inches. Is that rain I hear? Or is that just the air? Never mind. But so a lot of rain in 2003. So kind of the take-home message here, just if we have low snowpack, a year with low snowpack and low summer precipitation, some of our lakes are going to dry. This doesn't seem all that shocking. Just a side note, people who are looking at climate models and global warming, that sort of thing, are predicting for the Sierras over less and less snowpack. And so if we see a lot less snow up there, or even more variability in it, it could create a lot more years where we're having our lakes dry up. And remember, the permanent lakes are filled with fish. So next here, you've seen this slide already. What I've added to it, and can you see it? Can you read this? I hope. What I've added here is average number of egg masses seen per year. So in Lake 2, we see 43 egg masses per year. on average. And the depth then, maximum depth is 1 meter, and then the number of years that it dried up. So Lake 2 dried up 4 out of 9 years. So contrasting Lake 2 with, say, Lake 1, which is very deep and never dries up, it is only showing, on average, 1.5 egg masses laid here per season. Remember, there's fish in this lake. And so either the frogs are not breeding here, and there is suitable breeding habitat. There's plenty of the warm, shallow, silty areas, at least as much in Lake 1 as in Lake 2, but they're just not breeding there. Either they're not breeding there, or the eggs are being eaten so quickly that we're not seeing them in the surveys, in the egg mass surveys. Lake 5 on average has 14 egg masses per year and is a bit deeper and has never dried up completely. Lake 20, 30 egg masses on average, and has never dried up either. And just point out another lake. Lake 7 is fairly shallow, and it's dried up at least one of the years up there and has gotten very low. The rest of the lakes, you're just not seeing very much breeding activity at all. Like I said before, 87% is taking place in these 3 lakes here, Lake 2, 5, and 20. And as you'd expect by just looking at the number of egg masses, these are the maximum number of tadpoles present in the lake. And if I had showed you this graph, looking at averages, it would have shown the exact same relationship. But you can see lots of tadpoles in Lake 2, quite a few in 5 and 20, some in 7, and then just not all that many in the rest of the lakes. They're not big breeding areas. And again, Lake 1, it's huge, it's permanent, but not very many egg masses. So with Rana muscosa, if you remember, it needs 3 years of water to metamorphose to go from tadpole to adult. We would predict that a lake's recruitment rate would be dependent not only on the amount of breeding taking place, but also whether or not the lake persists to the end of the summer. Again, we're saying that lakes that never dry will have more consistent recruitment than lakes that intermittently dry up. This is, beginning of season in 2005, which was actually a wet season, and the end of the season it dried up. And this is what we see. The top graph is showing maximum number of metamorphs present by year in permanent lakes, and the bottom is showing lakes that are prone to drying. And again, it's the number of metamorphs, these being examples of our metamorphs, and they've had to survive at least 3 years to get to this stage, 3 years in water to get to this stage. So Lake 2, and the bottom is showing years where we actually recorded metamorph data. Before, you saw lots of egg masses in Lake 2, lots of tadpoles, but only 1 year do we see metamorphs. So only 1 year do we have actual recruitment going on in Lake 2. And that's because 97 and 98 were very wet years, lots of high snowpack, and rain. The rest of the time, it wasn't that they weren't breeding in Lake 2. They bred every year, but the lake dried up in 99, in 2000, in 2002, and 2004. So they never had more than 2 years of continuous water. And so, at the beginning of the season, when it's really wet, I've been told Lake 2 is connected to the big lake sometimes, and so a few tadpoles could get into Lake 1. But by the end of the year, they're not connected. It's not connected to any other lake, and so all those tadpoles, the thousands of tadpoles we're seeing, are just drying up and dying. They're not adding to recruitment in the basin at all. And the rest of the lakes that are that dry up every now and then also showing very little recruitment. There's a little bit of recruitment in Lake 7 because it actually did have 3 years of water, so we got a little bit there. So in contrast, we look at the more permanent lakes, and again, these aren't, really permanent. They draw down quite a bit. Lake 1 is the only one where it's permanent all the time. So we are seeing more consistent recruitment in these permanent lakes, even though there's a lot less breeding going on in them. One curiosity is this Lake 4. We've seen almost no egg masses there, but yet it's showing better recruitment than Lake 2 is. So a lot of the recruitment potential for Rana muscosa up here is being lost in Lake 2. So the take-home message again is lakes prone to drying show very low recruitment to the metamorphic stage. Another little aside with Lake 2, the frogs show very high site fidelity for breeding there. So they've been recruited in the past. Every now and then they get recruited and they live a long time. They keep coming back, they keep trying to breed. And every once in a while, I guess, they are successful. Otherwise, we wouldn't be seeing them there, I guess. Okay, in summary, the Rana muscosa tadpoles need at least 3 years to metamorphose. And predation is from introduced trout is probably limiting the breeding in our permanent lakes, Lake 1 and Lake 3. So this is just another example of the effect of fish stocking on Rana muscosa. It's possible, I think, that Rana muscosa 200 years ago were breeding in Lake 1. And so now they're being excluded from that and are being forced to breed in these very ephemeral places. And 200 years ago, their strategy of overwintering and growing large before metamorphosing was a good strategy. It was successful, and now that strategy seems to be proving less and less successful. I was also thinking when Gary Fellers was talking today about contaminants that when you have a pulse of contaminants with snowmelt, because all these ephemeral lakes are filled with precipitation. That's where they get their water from. They're going to have high contaminant levels at the beginning of the season, whereas Lake 1 is probably not going to show that pulse of contamination. It has a lot of water. The contaminants would be diluted. So this is another effect if trout, if they would have be breeding in this lake if trout were gone. So, another combination, deadly combination there for them. Again, a summary, 99% of the frog breeding we're seeing in Dusy Basin is taking place in lakes that are prone to summer drawdown or drying. All these lakes, except for Lake 1, are 2.2 meters or less in depth. And again, lakes that intermittently dry up show low recruitment of metamorphosed frogs. So in conclusion, low snowpack plus low summer precipitation equals lake drying equals low recruitment. And again, Lake 2 just goes away some years. As a little side note, this, as I said before, this was all very preliminary. No statistics have been done on it. Now the next step is to really tease apart things, look at statistics, look at the snowpack in a bigger way. And we have a lot of, we've mapped all our lakes for the last few years. During the course of the summer, we do GPS readings and look at drawdown and map the perimeter. So now we can tease apart this a little more instead of just looking at lakes prone to drying and lakes that aren't prone to drying, actually looking at lake persistence and partial lake drying, using the perimeters to calculate volume and water surface area. So that's the next fun thing I get to do. So thank you.